The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The broadcast is now starting. All attendees are in listen-only mode.
Hello, welcome everyone. My name is Leila Rhodes and I'll be your moderator today. Thank you so much for joining us here at NetCom Learning, a market leader in promoting lifelong learning, training, and talent development solutions. We are very excited to host today's event, AWS Discovery Day. Presenting today's topic is Brian Wu. Brian has 19 years of consulting experience in information technology industry, with his rich training experience within IT industry covering a wide range of skills and knowledge, from data center and network infrastructure to more recently cloud architecting and implementation. He has been training up the enterprises in all industry level verticals to help their adoption of cloud technology. Now, please bear in mind that this is just an overview of a very robust topic, but we do offer a collection of technical and business courses that can be tailored towards your specific requirements. And if you're interested in a further discussion about those, you can make an appointment with our learning consultants through our website at www.netcomlearning.com. Netcom Learning helps customers build innovative learning organizations by achieving a smarter workforce, adapting to change, and driving growth. We do this with a broad catalog of offerings, developing customized learning plans, and our global delivery capabilities. Since 1998, we have been empowering organizations with our managed learning services to help them reach optimal performance results and address challenges. We have 9 practice areas in which we specialize, and they encompass people, process, and technology training. Today's presentation is from the cloud practice area. Netcom Learning offers a comprehensive training portfolio for cloud courses, and our upcoming classes include various trainings on cloud practitioner, AWS technical essentials, security essentials, architecting on AWS, and many more. And private training to teams is also available, and the learning plans can be customized to the specific needs of that audience. You can also access a variety of cloud marketing assets, such as the free 1-hour trainings, free on-demand trainings, and blogs by clicking on the available webinar handout. And these offerings can also be found with a simple search on our website at www.netcomlearning.com. In this event, we will learn basic global infrastructure of the cloud, different methods of interacting with AWS, and more. The event will not only talk about the cloud concepts, but also the overview of security and compliance. Now, I'll just give you a quick overview of the logistics before we do get started today. To start with, you have the option to adjust the window size to your liking. You can simply hit the escape key and find the zoom button on the top left corner of your GoToWebinar viewer. I want to remind you that everyone has been muted except for our presenters, but you can feel free to submit any questions you have for the presenters in the questions pane, and we will address them at the end of the session today. And now, without any further wait, I'm going to go ahead and pass the time over to Brian to present today's topic. Thank you so much for joining us today, Brian. We are so excited to have you.
Okay, thank you very much.
Thank you.
Hello, everybody. I'm actually the authorized instructor from AWS. Today, we are going to take a look on the Discovery Day of the core concept of what is cloud computing and AWS fundamental. So let's take a look. Let's start. So what is cloud computing? Actually, this term comes to us around 2006, and I know everybody should know about Amazon, right? What does Amazon do? Basically, at the earlier years, they start selling the books, and then after that, they are just online shopping provider, and they face a lot of issues like some server goes down, a lot of buffer overflow, so that they cannot meet their customer need in earlier years. So they invest a lot on the IT infrastructure, and then after a few years, they start letting the customer to use their IT infrastructure. And nowadays, thousands or even millions of customers using worldwide. All right. So today's agenda, we are going to take a look on what is cloud computing and what is the benefit of using AWS Cloud. All right. So before cloud computing, actually, you need to build your data center to host your server, your web application. But you need to guess, as you can see the question mark, you need to guess what is our peak transaction, peak traffic. I can tell you, you can never guess correctly. All right, suppose you are hosting a game application in your a mobile industry. You can never guess the correct amount of your server. You may sometimes guess more, guess less. So if you guess more, then you waste your resources. If you guess less, then actually you don't satisfy your customer, okay, and you may even lose your revenue. And then the second question is your resources. You need to plan not only for growth but also availability. Everything happen. Your server may goes down, your data center may goes down. All right. So even storage. What is our appropriate storage? So before cloud computing, it is quite hard to do so. And then that's why since 2006, AWS provide this solution to the customer. Instead of building our own data center to host those server, web application, and any workload, you make it on demand. All right. As long as you need those resources, you can provision by using the internet, using the web service, so that for other customer, you don't need to invest a lot of equipment upfront cost. You don't need to rent the data center, the hardware equipment, the cablings, so that we provision the complete resources when we need, and we only pay for what we use. Okay, so in the cloud computing, originally a lot of people just think cloud computing is storage, and I can tell you it's much more than that. Say for example, we can put our server in the cloud so that it run our application, maybe web application, maybe some other type of servers. All right, mail server, authenticated server, whatever. So it is more than storage. Of course, you can store our data in the cloud environment, maybe just your static data and also your database. All right, and even run our application. Just any server you can run, you can put it in the cloud. So some company, I know around 10% of our customer put everything in the cloud. We call it all in. All right, but 90% of other customer, they have hybrid cloud. It means they still have some on-prem data center, maybe some server still running, some clients still running in their own data center. And then this is what we call hybrid. Or some company, they just start using the cloud originally. They just run everything on-prem. When the days come, basically like the rental, the period finish, okay, and then we move things to cloud. And I can tell you, many customer, they start using the cloud as backup, and something happened. Maybe some server goes down, maybe some natural disaster, and then they shift the load to the cloud. All right, or to meet the growth of demand. All right, that's how many company is using that. So the benefit of using AWS actually agility. We can create not only a single machine, but also a whole infrastructure very quickly. All right. If I just create a web server in the internet, it takes me less than 10 seconds. All right. Actually, in our real training, 3 days training, I will do a lot of demo. But here, we focus on the concept first. And then in cloud, another thing, good point is elasticity. Okay, so that you can explain your backend infrastructure if you got more traffic, more demand, and you can reduce your infrastructure to cut costs if you don't have that much demand. All right, think about suppose you build a game in the internet. All right, a lot of people paying, but maybe after 1 year, 2 years, okay, less people pay, and then you can easily cut costs by scale in. All right, and actually, it is very good for us to use the cloud because the cost is much lower normally. Because in AWS, they have economic of scale. All right, they can keep the cost very low so that they charge you with a relatively low price, comparing you build everything on your own. And then for rapid deployment, actually, as nowadays you can see in our mobile application, we have update almost every day. How can we do that? Before using cloud, it takes months to update your application. But now the life cycle is much quicker. Okay, to have your application 1.0, 1.2 1.3, in a week, you can have your application released a few updates. All right, so those are the benefit. If you take a look more inside, agility, and then here we focus on fast innovation. We don't need to wait for additional resources. Suppose in traditional environment, you may take months for ordering the server, delivery, put your server on the rack mount, cabling. Now for cloud, it just takes a few seconds for you to increase your compute and storage resources. So this related to the agility. And then for elasticity, as we mentioned, we can easily scale out and scale in to have more server, to have more storage easily, and also stream down to cut our costs, scale in when, say for example, the pandemic, we don't have that much of demand, then we can save our costs easily. Okay, and then cost saving. Actually, one very interesting point is that we are using the cloud trade the capital expenses for variable costs, just like the electricity, the aircon, the water supply. You don't need to build the equipment. You just turn on the button, and then you can enjoy the aircon. You can enjoy your water. So this is just like variable expenses. Okay, and as long as we don't need to build a data center, that's why we don't need to do the maintenance. All right, like we don't have the server rack, we don't have the hardware maintenance, data center maintenance, aircon costs for the data center. So it reduced a lot of costs just on the maintenance. And in the cloud, normally most of the service you pay as you grow. You start. You can test, you can examine your application easily. Okay, you only pay for what you use. As long as you finish testing, you can shut down or even terminate those resources in order to cut all the costs. And then for rapid deployment, a lot of people nowadays need to do some testing for their web application or other workload. In cloud, we can use the automate method. All right. To build everything. We call it infrastructure as code. We can build the whole infrastructure in minutes. All right, it may include database, web server, and also some load balancing, DNS, whatever service. Okay, normally for my past 20 years experience, actually for cloud, I play with cloud for around 10 years. Most of the time, within half an hour, we can spin up the whole infrastructure. So it's really, really quick on building the whole environment. And then let's take a look on AWS Global Infrastructure. I can tell you that AWS is the first guy to provide a cloud service. Some other competitor like Microsoft Azure and then Google Cloud. AWS start at 2006. Azure and Google Cloud, they start at around 2010, 2011. So this is the first guy, and now for global footprint. All right, as you can see in this picture, you can actually search this term AWS Global Infrastructure in your browser, and you can find all the updated information. Nowadays, as you can see, there are more than 20 regions. Okay, we need to know the terms region. It means they have a very large deployment. Okay, so that we can use most major service. Say, for example, we can create our virtual machine there. Next module, we will talk about the service. The virtual machine in AWS, we don't actually call virtual machine. We say EC2, Elastic Compute Cloud. Say, for example, you can also use some storage service like S3. So this is the region. The region we can use the major service. And not only this 25 region, but also you can see the line in between the region, right? This is dedicated cable provided by AWS. They have the fiber link connect all together, the world all together. Say, for example, in US, we have 7 or 8 region. They have this very fast link connect all together. And then connect to Europe, Asia Pacific. And as you can see in this picture, there is some red dot. Okay, say for example, let me point my mouse here. As you can see, under Hong Kong, there will be Manila, or in US, you can in Texas, in Orlando, they have some red dot. Nowadays, there are as many as 230 red dot. Actually, they are called point of presence or edge location. In those edge location, AWS still have some deployment, not very big. We can use just a few services like the DNS service, like the content delivery network. We call it CDN. In AWS, it is CloudFront. So we still have some service provide. So the global footprint is really, really big. So for region, what is the definition of a region? It's a separate geographic location isolated with each other in the AWS global footprint, global infrastructure, so that to serve the customer around the world. We now have 25 regions. Inside which region, we have something called availability zone. Okay, each region, we should have at least 2, and most likely more than 3 availability zones. So what is availability zone? Okay, in AWS point of view, the availability zone is basically a collection of data center. Actually, the definition of one availability zone is greater than or equal to 1 data center. So inside an availability zone, maybe there are 3, 4, 5 data center, and each data center, AWS put thousands or even millions of server into that data center. All right, so that it provide the disaster recovery. Okay, say for example, in Virginia, we have 6 availability zone. Each availability zone, we got 4 or 5 data center. So just in Virginia, we may have more than 30 data center to run our service. So for availability zone, normally there will be less than 100-kilometer array. So that in one availability zone, if we have some natural disaster like the fire, earthquake, or tsunami, or whatever, typhoon, then even if one availability zone goes down because of the natural disaster, we still have our application, our workload running in another availability zone. Okay, so this is how we isolate any potential natural disaster. So all the availability zone interconnect with each other with a very fast network. Okay, this is a fiber link, so that you can treat them as a single network location. So as a customer, for your production data server, it is better for us to build it in multiple availability zone. We call it multi-AZ. Okay, so availability zone is inside the region, and then point of presence. And before we call it edge location. Nowadays we got more than 230 edge location to run a few service like the DNS service, we call it Route 53 in AWS, and then we also have the CloudFront, the content delivery network. A lot of companies use those content delivery network to distribute data to their customer. All right, like broadcast company, like bank, they also use those content delivery network. Okay, so this chapter, just a few slides, we just take a look on what is cloud computing and the benefit of using AWS Cloud. Of course, agility, we can spin up the machine and the whole infrastructure quickly. Elastic, we can scale out, scale in easily. And then cost saving, all right, because the economic of scale provided by AWS, so that they will charge you in a relatively low cost comparing you build all the data center, all the servers on your own. And then rapid development, not only the first time, but also ongoing, the application life cycle. So this is just the first overview, and let's take a look on the second part here. we will take a look on the detailed service. So let's go on. So here in this module, we will take a look on some core service provided by AWS. Nowadays, AWS have around 200 very big service, and then they have more than I think 8,000 features. Okay, some minor features. Say for example, a load balancer, all right, a security group, a network, firewall rules. It's just kind of features. But big service, we can have more than 200. Some of them related to compute, some of them related to network, database, application. So here we will take a look on some core service. What are they? Okay, and then next module, the last module, we will take a look on what is how we are going to handle the security in the cloud environment. So in this module, we will take a look on some core service like compute service and storage service, database service, and also network service. And after that, we will have some MC question. I hope you can try, take a look, see whether you understand the concept. So let's take a look on the first compute service. In AWS, we have most people use this service. We call it Elastic Compute Cloud on your left-hand side. That's why we call it EC2, all right? Because it is Elastic Compute Cloud. Let me get my plan. So how do we name those services? Elastic here is basically, it means we can easily increase the hardware resources of your virtual machine. And as you can see, cloud, just the compute service is running in the cloud, running in AWS data center, running in AWS region, okay, to be more specific. And those are computer, virtual machine, okay? Elastic, it means that you can easily change that machine to be a very big, giant virtual machine with a lot of CPU memory. But you can also reduce your cost by lower your resources, okay? So it is flexible. And actually, in AWS, you will see a lot of service starting from E, okay, like Elastic Load Balancer, Elastic Block Store, Elastic Map Reduce, because it is just like flexible, okay? So this service is just virtual machine. And not just a single virtual machine, but also for EC2, we have auto scaling. It means that maybe at the beginning, test with one server. And then after we go to production, all right, we have two. And suppose you got more and more demand, you can scale out to have more web server. And at nighttime, think about Amazon.com. Nighttime, maybe still we have some customer buy things online, but normally less comparing with daytime. So we can just cut all those resources, okay? So that's why the icon, as you can see, two arrow is facing out and two is in. It means scale out and scale in, okay? So this is EC2 auto scaling. Not just EC2, but also many other services provide auto scaling. Even database, they can scale. In database, they actually scale with more node, all right? Suppose originally I got only one node for write, one node for read, and then we can scale more node to handle those read traffic. In some other service, we also have auto scaling. And then Elastic Load Balancer. Traditionally, if you are really a network guy, you may heard those names like F5 load balancing, NetScaler, Citrix NetScaler, and also Cisco, all right? There are some network device. Traditionally, you need the hardware equipment or virtual appliance. But in AWS Cloud, we can easily create those load balancer, okay? So that it can distribute our traffic into backend web server. Just like in my diagram, I can create an Elastic Load Balancer. This is a managed service so that when traffic comes in, and then we distribute the traffic into our backend web server. Suppose you got more and more traffic, and then the EC2 auto scaling create more server. We call it scale out, and then new traffic go to the new server. And then after the peak hours, after the peak season, we just cut all those costs easily. All right, so this is elastic load balancer. Okay, here in my diagram is related to the load balancing. Okay, it is a AWS managed service, so that AWS handle all those scalability, availability. And then next, nowadays, a lot of application is running in container. So on AWS, we can also run those containerized application by using the Elastic Container Service. It is really increasing. Actually, if you want to know a little bit more related to those container statistics, you can go to search this term, Cloud Native Computing Foundation. It suggests that in 2020, more than 90% of the application is containerized, is cloud native. And then for traditional application, 1/3 of the application is moving to those cloud native application. So container is one of the major cloud native service. And traditionally, a lot of people need to run some script, maybe those script running inside Windows or Linux. So you need to install your Windows OS and then have your library, Python, Java, Ruby application or script running inside. But nowadays, we can easily run those run those scripts by using AWS Lambda function. Okay, actually, this is what we call serverless technology. Okay, so you don't need to wait for the server to spin up. You just write your code, put there, and then actually the good thing is as long as the function is executed, you start paying for that. However, if there is no request, then you pay nothing. All right. So if you use EC2 or the hardware machine to run your function, you are paying every single second. Okay, but by using Lambda function, you just pay when the function runs. Okay, so it is a much better choice. So let's take a look inside. Okay. So first of all, for EC2, to be more specific, it is a sizable compute resources. So actually, you can build any server that you want. You may use it to build your authenticated server, file server, or even application server. Or you can also use it to build a database server. However, I need to say this term is that EC2 is unmanaged. What does that mean by manage? Manage means the scalability, availability, the patching, maintenance handled by AWS. But for EC2, because this is unmanaged, it means that the scalability, availability, you need to handle yourself. All right. So by using this virtual machine, we need to consider how we are going to update those virtual machines. Like if you're using Windows, maybe every week we got new updates. If you're using Linux, how we are going to patch those machines, you do it yourself. But this is a lot of people use EC2 because originally a lot of people running virtual machine in their on-prem environment. Maybe they are using Hyper-V, VMware, or some other customer. All right. So for EC2, we have a lot of pricing model. Okay, let's take a look. For pricing model, you can actually choose on demand. For on demand, basically you don't sign any contract. You just use when you spin up the computer, and there is a wide range of instance type that you can choose. Actually, I can show you a little bit demo by using this website. There is a very good website called EC2instance.info. Actually, you can select the closest region to you. Say, for example, let me select Virginia. All right. And then, as you can see, there are many instance types. Okay. And you can create Windows, or you can also create Linux. By using on demand, say, for example, you just pick the right choice for you. Suppose I want 4 CPU, let's say 4 CPU. 64 virtual CPU. Okay, just for example, like this. Okay, and then you are going to pay for, suppose you use Linux. If you don't sign contract, you are going to pay for this amount. Let me circle it. Okay, just 10 cents US dollar every hour. So actually, you can do some calculation. Every month, we got around 700 hours. Okay, so you are going to pay $74, all right, a month US for this machine if you keep running. However, if you sign contract, we call it reserve instance, you will enjoy a discount. Okay, for sign contract, you can actually sign with 1 year, or you can sign longer. Of course, you sign longer, then you have a more higher discount. So say, for example, 3 year, no upfront, all right? So suppose I select, now as you can see, it is 0.04. Okay, it's just 4 cents, okay, every single hour, because you sign a longer hour. So this is a very good web page to compare all the resources. Actually, some machine is relatively expensive, but they are very powerful. If you take a look, sort by the amount, as you can see here, 24 US dollar. But this machine is very powerful. As you can see, 64 CPU, 400 gig RAM. All right. So this is some idea on the pricing. If you shut down your machine, you don't need to pay for that price. Okay. Okay. So this is just some basic understanding related to the pricing. Okay. Let me get back my PowerPoint. So that's the reserve instance. And then for sport instance, actually the sport instance is you may enjoy a huge discount, but the resources is not guaranteed. Basically, the price is based on the demand and supply of AWS data center availability zone. So in some low season, you may enjoy a very, very low price. However, the resources is not guaranteed. Okay, you just bid for those resources. Okay, so we have those pricing model. Just change the pricing model. It may save you a lot of cost to run those computers. And then for EC2 auto scaling, we can easily add and reduce those instances. Okay, so that not only to serve the demand, but also maintain the application availability. Because everything happened, the whole asset may go down. Your Windows, your Linux, the virtual machine may hang. All right. So by using the auto scaling, we can keep those machine running, and then we can scale up. We can scale out. We can scale in. We can use those scaling by using performance, by using predictive. Say, for example, one example many people do it is that suppose the average CPU greater than 80%, then I add more machine. Okay, so we keep adding, and we can also set maximum. Suppose maximum, I just want to have 20 web server to save my budget, to save my cost, and then we can set something like that. Say, for example, the average CPU, if that lower than 20%, then I just terminate some instance. Okay, and minimum I should have, let's say, 4 machine to run. So this is an example how auto scaling work. So we can add instance when necessary and remove those to cut costs when the traffic is low, and you only pay for what you use. Okay, so this is just an example. In a week, maybe Wednesday, you got more demand. If you provision in your on-prem environment, let me use another color. If you provision in your on-prem environment like this, sorry, my pen. Okay, so Sunday, you waste your resources. If you provision like this, you cannot meet your demand. I mean, if you do it on-prem. So in cloud, we can scale out when we need. Okay, minimum, suppose I need 1 server, and then maximum, I want to have only 4 server. Okay, so that I don't have extra spending. Maximum is 4. Then we scale out when we need. This is the whole concept. And actually, I got some customer, they got more than 1,000 machine up and running, and then keep scaling out and in all the time to meet the actual demand. So elastic load balancing, it is really interesting. So that suppose you have a lot of web server. How can I direct those traffic to our customer? Okay, I don't want everybody go to a single web server or application server. So I want some customer come to here, some other customer come to here. So we can create the elastic load balancing. All right, so that it can do some health check if any server goes down, and then we just take it out. I don't want our customer to see the 404 error, web server error. Okay, so by using ELB, we can easily adjust the to do the health check, and then also balance our traffic so that every single server handle a certain amount of the traffic and the loading. Okay, you can also use the load balancer to distribute traffic across availability zone, even those availability zone is 50 or 80 kilometers away. Okay, so that's how we do the elasticity. Suppose in low demand, we may just have 2 web application server running, and the load balancing server distribute those traffic. And you got high demand, then EC2 auto scaling create more server, and then the load balancer distributed the new traffic to the new server. Okay, so it keep adjust meet your demand. Okay, and next one is basically the Lambda function. Before this cloud, without the Lambda function, we need to create server to run our code. Okay, no matter this is Python, Ruby, Java, .NET, or Go, something like that. So now we just write our function, put there, and then as long as we got request, and then the function run. Actually, Lambda function is event-driven. So something happened. Say, for example, if you book a hotel, and then it automatically do the rest of the job without human intervention. Maybe the hotel need to reserve the room for you, and then charge your credit card, and then also send you notification. So it is all happen automatically. So something happened, upload the order, all right, and then everything keep going and finish the job. So this is how we can think and use the Lambda function. But we don't need to provision server. This is a serverless technology. We don't need to wait. Just write our function and put there. And then for Lambda function, actually what we need to do is just upload our code to those service, and then you can make it event-driven, okay? And also run, we only pay when you run the function. If there is no request, if there is no running in your function, you don't need to pay a single dollar. So comparing with EC2, you can use EC2, run your script inside your EC2, but think about it, you are paying every single second. But for Lambda function, actually, it run and then you pay for that, okay? So this is just some kind of compute surface. Let's take a look on some other storage surface. For storage service, S3. Why we call it S3? Because we have this name, simple storage service. Actually, simple storage service is one of the service provided, launched in 2006. In 2006, at that time, they start the AWS cloud. There are 3 services, EC2, S3, and SQS. Today, we are not going to talk about SQS. If you're interested, you can join our architecting course. But for S3, actually, and then next is just object storage, the EBS. EBS is a block storage. Okay, what is block storage? Basically, it's just disk drive. Okay, the middle one is the disk drive, and then the right-hand side, EFS. EFS is a share folder or share file. All right, so you can think about that. One comparison for S3, actually, you just store your object inside those cloud storage. You can just upload your photo, your file, your backup file into S3. In order to put things to S3, we may simply using internet. However, in order to store those data in EBS, Elastic Block Store, you need EC2. This is the disk drive of your EC2. One thing very interesting, if you upload 10 gig data to S3, and you want to change something, you need to upload the whole object once again. However, for EBS, actually, this is a disk drive. Suppose you got a 10 gig disk drive, and if you just change one meg, they actually just change that one meg. So AWS will say S3 is fast and EBS is faster because it is a block storage. We only update renew those new block. So EFS is just a share folder. Okay, let's take a look in more insight. So S3 actually a lot of other X3 is not designed for end user. If an end user need to put something in S3, they need to create AWS account, they need to use create a bucket, use the API call. But a lot of company in the middle create some client application in their mobile application. Suppose let me use this example. Let's say Dropbox. Okay, Dropbox early years they use S3, and then a few years before they start building their own data centers to store those objects. But around half a year before, they start moving back to S3. Okay, because S3 provide a lot of very good features, like the cost is very low, very durable. Let me say it this way: any object you upload to S3, they will at least have 3 copies across availability zone. All right, those availability zone may be kilometers away. So you got 3 copies in the east side, west side, and north side of your city. So it is very less likely that you will lose all those copies. That's why AWS suggests the durability. We have 11.9. The only chance you will lose your data is that all the availability zone goes down. So that is just 0.00001% chance. Okay, that's how they guarantee that your data is very durable. Okay, in order to upload data into S3, first of all, we need to create a bucket, and then we can upload using the console. But to be more efficient, it is likely that we can use the command line. And if you're a developer, you can create your application by using the SDK so that your application can easily interact with S3. Okay, so let me just do a very quick demo here. So if I go to this service, I want to show you a little bit demo on what we mentioned. As we mentioned, we have some global service, right? Global bind service. For Route 53 is a DNS service. As you can see, we don't need to select region. All right. So because they are in the 230 edge location, not inside the region, we don't need to select. If you get your DNS domain name, it is worldwide. All right, in the edge location, not in the region. Say, for example, another service we call DynamoDB NoSQL. This is a region bind service. So after it load, you need to select the region. Say, for example, I select Singapore, Virginia. Your data is actually physically stored in those regions. So this is region binding service. Okay, let me go to S3. I want to show you S3. Okay, the first thing you need to do is create a bucket. Okay, suppose I create a bucket. The bucket must be unique, the name. All right, let me just put in, say, for example, Singapore. I just keep everything default. And then, yeah, after I create a bucket, this one, move bucket 99. And then I can upload by using the console or using the command line. By using the console is easier, all right? So this is the photo, okay, I took in some event, all right? So what I can do is basically just drag the photo here, and then you might answer some question. Oh, are we going to publish to the world, or just myself, only myself, I can see those content, and then there are some more options. I just keep going. So after that, the data is uploaded. It is now in the cloud, but by default, only yourself can open those objects. Let me show it here. Every object in S3, we got a URL. All right. That's why the bucket must be unique. If you are just copy this link, it means in the internet, the world cannot access my object. All right. But if I click this open, instead of using the link, everybody can use the link, right? But if I click this open, it means that myself, it recognizes my account, so that I can see the photo once again. I can access the object myself. All right. So this is how we interact with S3, a very quick demo. So I just show you how to create a bucket, how to upload a photo, and that is really a lot more on S3. Say, for example, how we are going to move to some cheaper tier, how we are going to upload if I really got a huge amount of data to backup. Many people store their on-prem data to backup in the cloud. They use S3, and a lot of service inside AWS, their backup features is using S3. Say, for example, before I talk about EC2, the storage of EC2, when we do the backup, they actually store in S3. All right. So this is if you use AWS, most of the time, I think more than 90%, you will use S3 to store something. Okay. And the other thing is Elastic Block Store. Elastic Block Store is just the disk storage. It is super fast because it is block level. If you're using Microsoft Windows, the block is just 4K, 4KB for every single block. If you just update something, you just update 4K instead of the whole disk. Your disk may contain more than 500 gig data. So the EBS is for S3, as we mentioned, we got 3 copies. For EBS, we got 2 copies. Anything you upload, okay, they will be replicated within ASAP. In other words, EBS is ASAP bind. All right, but S3 is region bind. Okay, as I showed you before, Route 53 is global bind or edge location, bind in the edge location. So we can spin up those volume in minutes. Okay, suppose I want to have 500 gig hard disk. All right, you can just get your hard disk within 1 minute, I think. Okay, so and we also got a lot of tier so that you can pay, you can optimize. Actually, if you want to load a little bit more than on pricing, you can search something like that. Let's say S3. If you take a look on the pricing, and then you can take a look. First of all, you need to select the region. Okay, normally US is cheaper because the cost is lower. All right. Say, for example, here, if you put your data into S3, this is 0.023 per gig. Okay, already you got at least 3 copies across availability zone. Okay, and then if you take a look on the EBS, you can search like this, AWS EBS pricing. Okay, it is very transparent, the pricing. For the block storage, once again, you select which region you are going to take a look. And then if you compare with S3, here, 0.08, okay, if you compare here, 0.02, S3 is much cheaper. Okay, and in S3, we can have a lower tier. Okay, if you go to the lowest tier, okay, $1, you can do some calculation here. $1, you can store a terabyte data. You cannot even use $1 to buy a hard disk, but you can store 1 terabyte of data. However, if you put those data into deep archive, at least you need to store half a year. Okay, and then in order to retrieve those data, you need to wait around 12 hours. Okay, so we got different tier. For EBS, we also got different tier. All right, some is faster, some other tier, but is higher the cost. Some tier is cheaper, but relatively slow. So this is how we select the EBS volume. We got different tier. We can spin up very fast. So here in this slide, as you can see, as I can show you, we got default, the general purpose. But if you want to have a fast hard disk, okay, you can use the provision IOPS hard disk. And then you can use some cheap hard disk by using code. They are much cheaper, okay, comparing with other type. So different pricing model for different tier, different types of hard disks. So for EBS, actually, this is just the disk drive. You create your window, you create your Linux, you can add some more. If you're using Windows, you can add D drive, E drive, F drive easily, quickly. All right. So this is EBS volume. Let me show you how quickly we can in order to create those EBS volume. Let me just go back to EC2, do a very quick demo. So let me start my computer first. Okay, now this is the computer are running in one of the region. Okay, actually, in order to spin up a computer, it is very fast. Let me do a very quick demo. Suppose I create a Linux. It takes 10 seconds. Okay, and then I can create a machine. And then I don't explain all the details. If you're interested, welcome to join our course. But I just want to do one thing. I don't just want a single Linux. Let me do something, run some Linux script. Is there any Linux people? By using this script, we are going to create the Apache, install the Apache inside the Linux machine. So I just keep everything default. And then because I'm going to make a web server, so I need to open the port 80. Okay. So next, and then next, just keep most of the things default. So it is creating this new one. All right. So if I using this IP address, and then actually I can connect within 10 seconds. So if I go to the location, I store my key pair. Key pair is just like the password. And then I use my key pair, and then just one command. I can connect to my Linux, okay, in Singapore. All right. So and what I did is actually I create a web server. If I copy this IP address, if you can access internet using your phone, your whatever, in your browser, just type this address, 18.140.59.140. Then you can see my web page. Okay, within 10 seconds, I can create a web server. Okay, but I didn't do any editing. I just keep the default page. So it is very fast to spin up. Think about in on-prem environment, it takes days in order to just configure the firewall. All right, but in cloud, it is very easy. Okay, you can access by using any browser as long as you can connect to the internet. So another very quick demo is that I can connect to my window. So suppose this is my window and this is the IP address. I'm going to remote to my window by using remote desktop. Okay. Yeah. Once again, a few seconds, I can access my windows in the cloud. And then for this window, for those Windows guy, I can show you that this is the computer running in the cloud. I can go to computer management. And then this management, as you can see, I got only one C drive. Before we talk about EBS, okay, now I've got 5 machines. Okay, here, 1, 2, 3, 4, 5. And then I got 5 volume. It means 5 hard disks. I can easily create a new hard disk. So I just put 1 gig, okay, and then put it in that ASAT availability zone. We mentioned availability zone, okay. The EBS is ASAT by, and then 1 gig volume. After that, just a second, the hard disk is created, and then I can mount to attach the volume to my server 1. I don't need to turn off the computer. Just a few clicks, I can show you that the disk is already there. And then you can format. You can use this drive very quickly. All right. So this is the EBS volume. And then here for EFS, EFS is basically a shared storage. You can store a petabyte of data. Okay. EBS is dedicated network storage to a single instance. Okay. But if you want share folder, then we use EFS so that multiple EC2, even across ASAT, can mount the same disk drive. All right. So it is elastic, a share file, is cost efficient. For any pricing, you can simply search AWS EFS pricing, okay, for details. So the time now is 1 p.m. How about we take a quick break, around 10 minutes, and then we come back and continue more details and then more demo. All right.
So, that sounds great. Let's go ahead and do that then.
Okay, thank you very much. See you 1:10.
Okay. Hello? Wonderful. Let's go ahead and jump right back in for the rest of our presentation. I hope you guys all had a chance to stretch your legs.
Okay, let's continue. The next area we are going to talk about is database service. For database service, actually, we have really a lot of service. First of all is the RDS, Relational Database Service. This is related to if you're using Microsoft SQL, Oracle, MySQL, Progress Database, you can use this service in the AWS cloud. And then nowadays, a lot of company use NoSQL. In AWS, the first choice of your NoSQL is DynamoDB. And another service called DMS, Database Migration Service. It can help us to migrate our on-prem database to AWS cloud. So for relational database, it is a fully managed relational database service. What does that mean? It means that AWS will handle the availability. By default, when you create the RDS instance, everything will be backup, all right? But by default, just backup for 7 days. If you want to backup for a longer period, you need to do the manual snapshot. And then the patching will be handled by AWS. Maintenance, because you cannot even touch the underlying OS. But it is very easy, so that if you click, you can spin up your database. Normally, for MySQL, it takes around 5-10 minutes, and then everything ready. Think about it. If you do it yourself using EC2, it takes maybe a relatively long time to just install and configure those database. All right. So relational database. Inside relational database, nowadays we got 6 engines. So that if you in your on-prem environment using Microsoft SQL, Oracle, sorry, and then MySQL, Marina database, you can easily change. You don't even need to change the store procedure, your database script. Then you can easily move to the AWS cloud. And then for RDS, you can check a box. We call it multiple AC or production, and then it will automatically create a standby. Suppose the consideration is you pay a double, but you already have a hot standby. If you don't create a multi-AC, you just have the backup. Think about if you've got 1 terabyte of data and your primary database goes down and you need to restore the backup, it takes maybe hours in order to restore all the 1 terabyte data. But when you create multiple AC, you will have another secondary in another availability zone. Even the first availability zone goes down because of any natural disaster, it will come up automatically. You don't need to do anything. And actually, they will create another secondary for you. And your application use the same endpoint talk to the database, so that your application, we don't need to change the code, modify anything. So that, but the standby is just for standby. You cannot do anything in the standby instance. However, we can create those read replica for read traffic. Suppose I want to do some reporting. You can create a read replica in the same asset, in another asset, or even in another region. Okay, so that after the heavy reading, after the reporting, you can terminate to save your cost. You can create those read replica in another region for disaster recovery. Suppose the whole region goes down, it may happen because of a very big earthquake. Okay, no one knows, right? So you can make those replica in the new region become a new master. The most important thing is you don't lose your data. So this is just some features provided by RDS. And for DynamoDB, this is a NoSQL database. Nowadays, a lot of data is not relational. Say, for example, the game result in Amazon, the shopping cart, all right? And then for many hotels, you can put some comment after you stay in the hotel. Those are not very strict data. it is very good to store in NoSQL, because NoSQL could be very, very fast comparing with the traditional relational database. Can be 5 times, 10 times, or even 50 times more faster. Because in DynamoDB, we don't have the concept join relational. We just simply put the data there, and then when you want to get the data, you just simply scan, look up those data. And DynamoDB is a service, NoSQL on SSD. In AWS, we got some other service called Elasticache. It's NoSQL in memory. The data is even in memory, so it's super fast. And then for DynamoDB, this is also a serverless technology, so that you don't need to wait for any provision. For RDS, you need to wait 5-7 minutes in order to use those databases. But in DynamoDB, the first button you click is create database. Create table, and then you can actually put your data. Okay, you can use immediately. So to your client side, there is no server at all, and then it is very fast. So this is DynamoDB use case. Suppose you're building the serverless web application. Traditionally, our application holds in computers, the virtual machine, like EC2, like your on-prem Hyper-V, VMware, or even physical machine. But nowadays, more and more companies build with all the serverless technology. Actually, S3 is another serverless technology. Just like in my demo before the break, I create a bucket, and then I can actually store those data inside S3. I don't need to wait for any provision. I don't need to wait for the machine to spin up. So this is what we call serverless technology. And many companies also use DynamoDB for mobile app, game, Internet of Things. Okay, so this is just some use case. How we are going to migrate our data into AWS? You can choose this service, database migration service. Actually, we create one replicated instance in the AWS side, and then we connect the source. The source can be your on-prem environment, can be Microsoft SQL, Oracle, other open source database like MySQL. And then after you create the source, you create the target. The target likely will be RDS, but could be other like Redshift, could be the DynamoDB. So after you create the source and target, we create a task so that it's just like a job to move our data. It can be one time or ongoing. All right. Suppose you really want to use AWS as your disaster recovery location. Your on-prem goes down, and then everything's been up in AWS. In that case, you choose ongoing, so that I keep replicating our on-prem data into AWS. The AWS database is keep up to date. So this is a service. One very good features provided by DMS, the database migration service, is that we can even change the engine. Suppose you are using Microsoft SQL, but I want to change to use MySQL. Actually, this is database migration. It takes really long time to do in on-prem environment. But by using DMS, you can easily move those data from Microsoft SQL to MySQL to progress to even Aurora database. Because inside DMS, we got one tool called schema conversion tools to handle those schema changes. Okay, so we just mentioned a few services related to database, and next we are going to talk about the networking service. For networking service, first of all, we have the VPC. Okay, virtual private cloud. Virtual private cloud is a regional service, so every region we can create the VPC, and the VPC is basically the networking service provided by AWS. And why do we need to learn about that? Because the EC2, the RDS, they all live in VPC. Okay, some student in my class say, "Oh, I can just put everything in the default VPC. In every single region, there is default VPC." However, I can tell you that actually the default VPC only contain public subnet. It means that you can connect to the internet, but the whole internet can visit your your things, your server, your database. Are we going to put our database in the public subnet, in the public internet? No. So it is better for us to learn how we are going to create a VPC, create a subnet. All right. Let me draw a quick diagram. Is that we create a VPC, virtual private cloud, and inside we can create those subnet. We can create public subnet so that we can easily go to the world, but the world can easily find us. Okay. We can also have private subnet so that you still can go to the world through something like what we call NAT, network address translation. However, put our database, our backend server, our AD server in the private subnet so that you still can go to the world, but the world cannot find you. All right. So this is a better design for creating the VPC. The VPC is just the AWS networking. All right. Another thing is Route 53 is just the DNS service provided by AWS. Actually, some customer, even if you don't create any EC2, S3, any load balancer in AWS, you still can use Route 53 because this is just DNS service so that you can have your all on-prem environment. I know that many people start using AWS by using S3 first, okay, and then after months, years, and then they gradually use some other AWS service. And then Direct Connect is just connecting our AWS cloud to our on-prem environment. And CloudFront is basically a content delivery network to distribute your traffic to the world. All right. So let's take a look in details. So for virtual private cloud, actually is in the AWS cloud, and they are virtual networking. Private means the private IP address. Inside a single VPC, all of your instance got the private IP address so that they can talk to each other. You can create multiple VPC so that those servers can talk to each other, but not to another VPC. Suppose you got multiple projects running in the AWS cloud. This is project 1, this is application 2. So you want them talk to each other. This talk to each other, but not talk to other VPC. So that's why we call it private. You can imagine this is kind of isolate environment between those workloads. Okay, and then we can easily create by using the management console or any API call, so that many services live in VPC, EC2, RDS, and then also the Redshift and the EBS volume. So, but some other service not living inside VPC. Let's say S3 DynamoDB that we just mentioned, and VPC can integrate it with other network technology with your on-prem environment by using the VPN and also by using the Direct Connect. So actually, when we draw the diagram, we will like this. In my actual class, I need the student to draw the diagram or even present. The first thing is draw the surface object in the right place. So first of all, VPC is inside region. It's a region binding surface. Say, for example, if I draw Route 53, should be here, outside the region, because this is a global binding surface. So inside a region, we may have one or more VPC, and then we can have subnet, okay, public subnet, so that they can go to the world. Private subnet, maybe I don't allow those instances go to the world. Maybe we can connect to our on-prem environment by using VPN or Direct Connect. All right. So our instance is living inside those subnet, and those subnet is inside VPC, and that's how we draw those architecture. Okay. Next, for another service is Route 53. It's basically a DNS service. Actually, I got my domain name from Route 53. If you want, it is very easy. Just go to my website through www.brianwudemo.com. All right. Actually, this if you click refresh, you can see blue and green. How did I did it? Is basically I got two servers. Server 1 is blue color. This is blue, and server 2 is green color. And then I create a load balancer before we talk about the ELB, right? It distributes the traffic. I make it blue and green so that you can identify which server you are visit. But here, the endpoint is not so friendly. So I use Route 53, a DNS name, www, and then buyandrooldemo.com, and then point to this. So when you visit my website, you can access the load balancer, so that I don't need to remember the endpoint provided by the ELB. So just a DNS service. And for Route 53, we can do health check. We can do latent-based routing. It provides a lot of features. So it's a highly available DNS service to transform your domain name into the IP address. So you can create a DNS record easily. Yeah, that's how we interact with DynamoDB. Let me just take you there to have a look. If I go to Route 53, this global bind service, and then I grab my domain name there, buyandrooldemo.com, and then you can create your own record, just like any other DNS. Okay, this is my record. Before I showed you www, point to my application load balancer. It is very hard to remember this one, right? So it is much easier to remember. Okay, so this is how it works. And then for distributed the traffic, people always, the first time they visit your website, go to the DNS name. Okay, no matter they use the laptop, notebook, or use your mobile application. So when they type the address, and then the Route 53 resolve, and then redirect those traffic into your ELB. And not just ELB, but also it can direct those traffic to your on-prem environment, or even rating. Suppose I want 80% of the traffic go to my on-prem and 20% of the traffic go to ELB. You can do so by using Route 53. Okay, and the next one is direct connect. So we need to think about that. Suppose now I have VPC, I have some server workload EC2 running in the cloud. Do we need to connect our on-prem to the cloud? Suppose here in my on-premises environment, my own data center. Okay, if you don't want to connect, yeah, they are just separate. Suppose I want to connect, I don't want to go through the internet. I want a dedicated network with a higher security, faster speed connection, so that we can create those direct connect in order to, just like the fiber link, connect your own data center to the VPC. This is the direct connect. The other choice is you can use VPN. For VPN, it actually goes through the internet. Okay, so the traffic may be affected by some internet issues. So for direct connect is a dedicated link between your on-prem environment and then the AWS cloud. So really a lot of companies already build direct connect so that they have the hybrid cloud environment, just what we mentioned in the first module. And then for CloudFront, it's basically content delivery network. It leverages the 250 edge location so that it brings our content close to our customer. Okay, so that the experience is much faster. And then I can tell you, it is much cheaper by using CloudFront. Not only the price of CloudFront is cheaper comparing with S3 and EC2, but also normally when you use CloudFront, you use caching. Your backend, the heat to your backend load balancing, to your backend infrastructure, may be reduced by 90% or even more, because you get from cache. All right, so that in this case, you can lower your backend instance. I don't need that much of instance. I can reduce the size. I can reduce the database because I got the cache. But think about it. What we are going to cache, fixed content, static content is the first choice. The video, the picture is the first choice. But dynamic content, maybe we still can cache, but a relatively short period of time, maybe just 5 seconds, 10 seconds. It really depends. The content delivery network. So for CloudFront, it is we don't need to sign contract, no commitment. You just pay for what you use, and even if you use it, it is really, really cheap. All right, and then for more details, you can check the Calvin pricing, and then here as I mentioned, video, static assets like the HTML, like the picture, is the first consideration. Just like this, maybe my original data is in South America, and then the people in Europe, if go through internet to watch my video, the latency is high, the performance is not good. By using caching, we actually store those data close to the user, so that the next guy come to visit our website, play the video, is much faster comparing with the first guy. So this is the content delivery network. So let's take a look on some knowledge check. So some question. Let's take a look. Which AWS service automatically distribute traffic across availability zone? Okay, as we mentioned in the compute section, this is the job of the answer is, I give you a few seconds. Okay, is it ELB, auto scaling, or Lambda function? The answer is, yeah, this one. Okay, the ELB. The ELB distributed traffic across availability zone. Just like my demo, the blue and green. The blue website is in AZA, the green website in AZB, so that if you touch my load balancer, it will distribute the traffic. Okay, even if one availability zone goes down, you still can access your application. So for second question, the EC2 is a service to provide highly available, highly scalable, high performance container orchestration. The answer is true or false? The answer is false. Actually, for this sentence, the container orchestration, we use the ECS, Elastic Container Service. Okay, so instead of EC2, it's ECS. The next question we are going to talk about is storage, related to storage, which is the best option for high performance block storage. Okay, and if you take a look, EC2 is not a storage service. It's a compute service, computer virtual machine. EBS and S3, they are both storage. However, S3 is object storage. Okay, so the right choice is EBS. As the name mentioned, elastic block storage. If you just change 1 megabyte, one block, they just change that block. But for S3, if you want to change anything, you need to upload the whole file again. Okay, so this is object level for S3, block level for EBS. Once again, S3 is fast and EBS is faster. We don't have slow storage, sorry. So true or false? For EFS, we can only store data within one single availability zone. The answer is, of course, false, because EFS is region bind service. Remember, we have free binding. Okay, global bind like Calvin, Route 53. Region bind, it means across the AZ. Like S3, like DynamoDB, like EFS, those are region bind service. Which service is AZ bind? EC2. We need to specify one AZ and also the RDS. All right. So for database, what is the best option if you want to put something in a NoSQL database? NoSQL means non-relational. As we just mentioned, RDS is a relational database. DMS is just for migration. Okay, move your database from on-prem to AWS. So the right answer is DynamoDB. Okay, DynamoDB is NoSQL on SSD. The data is actually stored on SSD. Okay, so NoSQL choice. This is your first choice. And for another database question related to which database engine, which database service provide multiple database engine, including Aurora, MySQL, Progress. Not only these three, but also the other like Microsoft SQL, Oracle, and Marina database? The right answer is RDS. Okay, this is relational database service. Lambda is just a function. Okay, to run your stateless function. S3 is just object storage. So last one, related to the networking module. For networking, what is the highly available scalable DNS service? Okay, as we just take a look in the networking service, VPC is virtual networking. Okay, create your subnet to contain the EC2, to contain the RDS instance. Route 53 is DNS service, and then Direct Connect is just provide a hybrid cloud, the connection between your on-prem and AWS cloud. So the right answer here is Route 53. Okay. And then, oh, sorry, here is the last question. What is the fast content delivery network? Okay, this is the Calvin, the AWS CDN, comparing with other competitor like the Akamai, like the Verizon. But here in AWS, our CDN is called Calvin. Okay, to deliver our content in a much quicker way, closer to your user. So this core module, we take a look on the basic service. Most people use those compute network database and storage service. Okay, so the final module for today is related to security. Okay. So security in the cloud is interesting. All right. Let's take a look. So for cloud, some students ask me those questions in class. If I put something in AWS cloud, does AWS do everything related to security? The answer is no. Let's take a look. In security, we have something like visibility. We need to visible to the object, the ownership, who is responsible for cloud network, and then say, for example, encryption and so and so forth and more. And auditability. If you do some delegation, what did they do? Okay, and then we need to control. We don't allow every people to create instance. Maybe just certain senior admin, we can create the network, the instance, and then agility. Okay, actually, I got some customer. Last week, I got a class 2 years before the student prepared to move to cloud. After 2 years, last week, I meet those students again. They're still preparing to move to the cloud. Okay, so just define what permission people have, the preparation for 2 years. So in order to move to the cloud, agility is a very big consideration. Not only meet compliance, but also move it fast. Okay, so share responsibility is a very key concept. It means that some responsibility is by AWS, is on AWS, and some other responsibility on customer. As you can see in the green color, the region AZ edge location we talk about, the compute storage database network service, we have some basic protection. However, customers still need to do a lot of things. Like if you create an EC2 instance, we have the OS management, the network firewall, encryption. So it means that we still got a lot of jobs to do. However, one key message is security in the cloud should be easier than on-prem. Because if you're doing this on-prem, in your on-prem environment, you need to do everything. Now, you shift some responsibility to AWS. Okay, so security in the cloud means the blue color, means what we should do. Say, for example, the OS, the patching, the application installation, the security group to control the firewall, the OS firewall, the network, the VPC. Okay, we need to create. Are we going to put our database in the public subnet? Okay, and then account management. This is what we still need to do in the cloud. And then security of the cloud, like the physical security, data center, network infrastructure, even some basic DDoS protection, distributed denial of service protection. you can enjoy. Simply you subscribe to AWS service. So in security service, let's take a look. Some related to identity access management, and some other related to detective, control, protection. Let's take a look inside. We got 5 areas to talk about. First of all, identity and access management. It means what is identity? Basically, who you are. Access management is what you can do. Okay. The following service is all related to authentication. IAM in AWS is authenticated AWS resources. After you log in, or say for example, you can create EC2, he can create bucket. And then directory service, also authentication, but not for AWS resources. Normally, it's for authenticated your OS and application. Cognito, this AWS service provide you to authenticate your mobile application. Your application, mobile application still need to authenticate. Normally this one for the world, this one for your internal application. Secret manager, we just store our encrypted secret there. Maybe password, maybe your credit card information, maybe your sensitive string, single sign. Once we authenticate here, we can not only touch AWS resources, but also your OS and application, your SaaS application. So let's take a look on the next area, detective control. Basically, a guard duty will show you, is there any abnormal behavior in your AWS account? Okay, suppose normally you do everything in Virginia, and suddenly maybe a whole new environment spin up in Tokyo. It is very abnormal. This is just one example what guard duty can do. Okay, any abnormal traffic. Inspector basically inspect your EC2 instance. Is there any vulnerability inside our EC2, Windows, Linux? Mazy detect that because S3 you store a lot of data. Maybe inside S3 you open your public your bucket to the public contains some confidential information. All right, like the phone number, like the name, like the credit card, like your private IP address. So it can detect S3 any data potential lose to the world. And then Security Hub is just central management console to control all this. So instead of going to each individual, I can go to one single location to control everything. That's the Security Hub. And then for infrastructure protection, every AWS account got basic shield protection. It means that technically for layer 3-4 TCP UDP attack, you will be protected. But for application layer protection, you need to subscribe. Okay, you need to pay a monthly fee to AWS in order to enjoy those application layer HTTP attack protection. You can also use the web application firewall service to avoid those like SQL injection, cross-site scripting, cookie insert, buffer overflows, that kind of attack. And then Firewall Manager helps you to move these rules to multiple AWS accounts. Suppose in a larger enterprise, you got 100 AWS accounts. We are not going to set those rules in those 100 AWS accounts. Rather, we will use the Firewall Manager. Sorry. Okay. Next, in AWS, likely you will store your data with some confidential or sensitive information. KMS and Cloud HSM, they are key management to have your data at rest. We say data at rest. When you store the data, we have the data encrypt. Certificate manager is for data in transit. In transit, it means that when you send those data out or in, the data is encrypted. The communication channel is encrypted. Okay, so they are both for encryption. One for storage, and the other is for the transit. And if most likely a lot of companies need to meet the compliance, you can use this service artifacts in order to take a look the compliance requirement. It's just document. You go inside and take a look. In US, what we need to meet. In UK, what you need to meet the requirement. And then IAM is basically the dedicated service, so that who you are, what you can do. We are not going to use root user to do everything. Suppose you got some staff, you got some dedicated admin, we create this service in order to grant permission. So inside IAM, we create the user. Every new user, we don't have permission by default. You need to expressly allow those users. However, it is not good to grant permission directly to the user. It is better for us to grant to group, even if you got only one user, because when the user leave the company, and when you got new user join to the team, you don't need to set the permission again. You just drag the user into the group, and then remove the user from the group, and then everything done. You don't need to revoke the permission. So this diagram shows you, say for example, in left-hand side, you got admin group, maybe they have a high privilege. You got some testing group, maybe they can just read and use the service instead of create or delete. Okay, so you can set permission according to different groups. So next, for the permission, we can use the policy. Actually, you just allow, deny what they can do. They can create bucket, they can list, they can download, the user can create an EC2 instance. There are really a wide range of permission inside AWS. And another recommendation is using the MFA. It means that not just account and password, but also some token like the Google Auth hardware token, a one-time password, so that even your account and password is stolen, all right, you still need extra authenticated, okay? And as we mentioned, AWS Artifact is just some document. If you go into that service, you can find in different country, different region, what are the security policy they need to meet. And most of the company, they need to meet compliance. Say, for example, your application accept credit card payment, you need to meet the PCI standard. And if you're a hospital, health company, you may need to meet the HIPAA. Different region, you may need to read. But most of the AWS customer can meet those compliance according to Artifact, according to the guideline. So let's take a look in this knowledge check. In this module, we will take a look on some responsibility from customer and then also AWS. If you take a look, who is going to configure the security group, the firewall, this is customer responsibility. And then if you just take a look on the color, for gray color is customer responsibility. For orange color is AWS responsibility. So who is going to AWS or customer configure the hypervisor? Of course, we cannot even go to AWS data center. So this is AWS responsibility. For patching in your OS EC2, so this is customer responsibility. For the hard disk, how we are going to throw the hard disk, destroy the hard disk, of course, this is AWS responsibility. And then internal network inside AWS data center, of course, this is AWS responsibility. And then install camera in the physical data center. Anything if you see physical data center is, of course, AWS responsibility. Last one, for encryption, S3, of course, this is customer responsibility. We need to check the box to do the encryption. So another knowledge check is that within your AWS account, you need to create all the policy in day one. Of course, this is not the case. You can easily create a policy at a later time. So the key takeaway for this module is security is shared responsibility, not just AWS. We still have a lot of work to do related to your network, related to your encryption policy settings. So this is the end of the last slide of the last module. I hope you guys enjoy. Okay, so let me see if you got any question. You can ask in the question area, and then I'm going to pass this time back to Lini.
Hi, yes, we are ready for you. So while everybody is going ahead and getting their questions into the questions panel, we are actually going to hear from Mary. And Mary is our director of product, or sorry, of vendor and product. She's going to introduce some promotions and event-related courses that you can take to kind of further what you learned today. So Mary, oh, is Mary not with us? Is it Eliza that's going to be helping us today?
Yes, ma'am. I'm
Oh,
sorry,
you guys
Mary. I
switched
just
it up
stepped
on
out.
me. Okay, well, Eliza, we're happy to have you just as well.
I'm glad. Thank you so much, Leela. All
Oh,
right.
did I make
So,
you the presenter or me the presenter? No,
um, me.
there we go. Okay.
Thank you so much. And great webinar, Brian. I was actually here, all of it, all through it. And thank you so much for doing such a magnificent, fantastic session today. So now that everybody is here, and I would like to take you through our other promotions, and if not promotions, other freebies that you can take away from the webinar. So just to let you know that you will be receiving the ebook for AWS in your emails quite soon. We're working on it. We're just compiling a list of everyone who's attended the webinar, and you will be receiving your free ebook on AWS quite soon. But to talk more about this, as a matter of fact, I am right now on our website. I'm pretty sure you've been here already at www.netcomlearning.com. And at any given point of time, if you want to go to AWS, the main page for AWS, where you can get everything that you need, all you have to do is either use this search box, put in AWS, put over here AWS, there's AWS right over here. You could just click over here, or under training, you also have under vendors AWS located over here. In all cases, you will be able to go to the AWS vendor page. You also have AWS over here, just in case you were thinking about it. So once you click on AWS, the very first thing, first of all, what you were learning today or what Brian was talking about today is mainly all about concepts. You want your concepts to be clear. And before you get into any training, either it's fundamentals or administrator or developer, solutions architect, it's very easy to get into these trainings once you have your concepts completely clarified to you. So I want you to come over to this page, and I want you to be able to go through this AWS certification roadmap. So once you click on it, I'm just going to open it in a different tab because I have to take you back to the same page. You will be able to see the entire roadmap, the learning roadmap, which has been actually created by AWS and Netcom Learning at your perusal, by the way. So if you're in a non-technical management or sales role, what type of training should you go for? And these are all links. Anytime you want to go to any of these trainings, you want to start with cloud practitioner. If you're a cloud architect, cloud architect accelerator, you have a course on that. If your job role talks about doing a cloud migration, if you're a developer, you're into system operations, administration, you're into DevOps. So the entire roadmaps over here are actually laid out for you. And as you all know, everything actually starts from the fundamentals, right? So if you want to take the fundamentals training with AWS, you can always come to us and you can take the fundamentals training with us. But we also have free e-learnings for you. So right over here on that same vendor page that I brought you to, there is free official AWS e-learning resources. And once you click over here, what you'll be able to see, as a matter of fact, are different kinds of AWS courses. So if you're into analytics, you want to do a course on networking, you want to a brief walkthrough of the entire course and so on and so forth. What does it comprise of? You could just come over here. You can either browse all, or you can choose exactly which stream do you want to get into, even for the AWS fundamentals for that matter. And you will be able to take your free e-learning from right over here. So it's all laid out under IoT. You have machine learning, you have storage. I love the security part, by the way. That's one of my favorites. AWS security, and then you have networking, media, analytics, database, and so on and so forth. I'm not going to read, I think I already read all of them out for you, so I'm sorry about that. And once you go in there, you just need to do, all you have to do is just watch the video, and the video will be available for you. And under each of these main titles, you will see that there's number of videos that you can actually go through and learn more about these. Like under, under AWS Internet of Things, you have a visual walkthrough, you have introduction, you have introduction to IoT one click, and then you have 11 other videos. I'm sorry, 9 other videos, eight other videos that you can actually go through as well. Now, there are organizations sometimes, and a lot of organizations actually come back to us and they say, hey, I don't understand. I have a team of people who actually need to take these AWS courses, but I don't know which course is suited for what person. And for that, what you can do is you can come into our solutions section right up top. You can come over here either from the main page, or you can come from here from anywhere you are in the website. So under the solution section, you have right over here AWS Learning Needs Analysis. We do it for you. It is absolutely free of cost. I think there is a cap on it. You need at least 30 to 50 members in order to do a learning needs analysis. Otherwise, the data is biased. So, you definitely want to have that team whom you would think are probably going to be good with the AWS trainings, and you could just click on the AWS LNA. You have that right over here, the LNA roadmap over here as well. I think there was another link someplace over here. Let me see. But anyways, you can come over here from the solutions with AWS Learning Needs Analysis, no matter where you are on the website. Now, under the learning needs analysis, if you want to find out what is part of the learning needs analysis, you want to see how it works, it's right over here. And what does it comprise of? First of all, for qualified organizations, there is absolutely no cost to run a learning needs analysis or an LNA. What does it bring for you? What does it do for you? It's a very simple and a 3-step process, as a matter of fact. And it kind of highlights on an anonymous level, what are your employee skill gaps? And what would be the right AWS training for a particular employee? And that is exactly how, you want to make a data-driven decision, and you want to make sure the decision that you are making for your employees or for your coworkers is absolutely correct. If you want to, this is what I was talking about. As a matter of fact, you have the LNA information kit. You can go through it if you want, and it gives you all the information on the LNA itself. It talks about, the contents, the process timeline, how you could train your team smarter. Just go through it, and if you have any questions, you're more than welcome to just put in your information over here. I know it's mandatory, but Google autofills for you. Just put in your information right over here and just submit that information with us, and we will be able to help you out with your LNA for your organization. That's all I had for today, but for other promotions, if you're thinking about other promotions, as a matter of fact, you can always come to our promotions page, and you have various promotions actually that you can go through. Go through our learning passes also. We call it learning passport sometimes. You can call it learning passes. So let's say if you don't have a team of 50 people or a team of 30 people, you have smaller teams, you're more than welcome to get into our learning passes and save huge on all of the AWS trainees as well. So yep, that's all I had. And back to you, Leela.
Thank you so much. And thank you for covering all of that. We really have had a wonderful session today. We are going to go ahead because we are out of time. We're going to just take a couple questions and then we're going to have to wrap up. So our first question is, this AWS Discovery Day webinar details are not showing under the My Portal or Student Portal, Netcom Learning Portal. Do you have anything that you can say about that?
Yes, they would not show up under your student portal because this was actually ran as a webinar and not as a master class. But let us know what is it that you need, and we will be able to help you out with that, definitely.
Should he just, he or she, I don't even know. I didn't even look. So should they just email at webinar@netcomlearning.com? Is that a good contact for
Yeah,
that? Okay.
perfect email address to send us an email to.
Okay. Our next question is, what is the difference between virtualization and cloud computing?
This is a very good question. Virtualization, you can run your virtualization even in your on-prem environment. But cloud computing is much more than that. We include database, storage, and also virtualization, networking, application development. So virtualization is just normally 10, 15 years before we virtualize the hardware. But cloud computing, I can say, is much more than that. Okay, but if you want to know more, please, you can join our class and take a look in more details.
Perfect. And our next question is, can you please send me the AWS ebook to my email? Are all those handouts and everything that they would need for this in the handout section, correct?
No, the ebook will actually be sent to all of the attendees, as a matter of fact, to their email addresses. So it would not be available in the handout section. In the handout section, I believe the only thing that you will be able to see is the learning resources, but the ebook will actually be, and the slides, of course, for the slides from the webinar today, but the ebook will actually be emailed to you. So give us some time. If not by today, then tomorrow you will definitely be able to receive it.
That is a great extra goodie for this. I do have a few people asking if there will be a recording session. From my understanding, there is no recording for today's session, which we generally do, but today's there is not. Is that right, Eliza?
No, actually, the session is being recorded and it should be available on our website within 24 hours. I can show it if you want exactly where they will be able to find it. Well, you usually receive an email from GoToWebinar, and it has that link for Watch Now. But if you want to view the recording for the particular session, you can always go to the webinars page, go under resources, go to webinar, and go to on-demand webinar.
Are you showing it? I took back the presentation on this.
This is your fault, Leila.
It is.
This one is
usually my fault, right?
Yeah, usually I take blame for you, but today,
Not today.
Not today. So under the resources section, you have webinars right over here. And at any given point of time, if you want to watch this webinar, of course, it's not there yet.
I believe
it has
Sadia said that this one is not going to be up. So I don't know for sure. I would say maybe check back on there. And
I would say check back on there. But if you don't see the webinar, hold on, let me see if there's an older one over here. But I know that the session is being recorded and GoToWebinar will be sending the Watch Now link in the email. If you don't get it, just send us an email. Same email address, webinars@netcomlearning.com.
Okay, and let's see. I think we have another question that is directed towards Brian. How do we make a diagram of our AWS architecture?
You mean to draw the diagram, the whole architecture? The best way is if you want to focus on the tools, there is a tool called Draw.io. However, this is the purpose of architecting on AWS, the course. In this 3-day, we will take a look on how we are going to draw in the right page, and then the student also need to present. Of course, we need to understand each service. Are they global buying, region buying, or ASAP buying, and put it into right order. And then we will discuss what is a good architecture. So we need to understand those services, and then compare and select the best choice. That's what architecting do. Okay.
Wonderful. And with that, we are going to have to go ahead and wrap up. I know we have other questions that people would like to get to, but we are running behind. So if you do have additional questions, you can send them to us at webinar@netcomlearning.com at any time. We are going to go ahead now and launch a quick poll to find out how many people might be interested in taking some additional training. In addition to what we had today, we have a lot of informative webinars that are coming up and other events. So please go to www.netcomlearning.com/webinars/ to register for any of those. Thank you all for joining us today. And thank you, Brian and Eliza, for helping present and make this event just awesome. And we want to remind you, you can send those questions to webinar@netcomlearning.com at any time. We hope you all found today's event to be very informative, and we look forward to seeing you back here very soon with us. Also, please feel free to tell your friends and colleagues about our events, webinars, and other courses. Once again, thank you, everyone, and have a great day.
Thank you very much.
Thank you, everyone.